This video demonstrates how to model decimal subtraction problems with base 10 blocks. To support student learning, the Works Clearinghouse Practice Guide on assisting students struggling with mathematics recommends using concrete representations like these base 10 blocks and connecting them to abstract representations such as this expanded notation. Subtracting decimals can be challenging for students, especially when the problems involve regrouping. So I'll model a problem that requires regrouping so you can see how helpful these concrete materials can be for building and applying this important place value concept. Okay, here we have our subtraction problem. 2 and 38/100 minus 1 and 52/100. The base 10 blocks are a great concrete material for representing decimals because the sizes of the pieces are proportional, meaning the sizes of the pieces show the relationship between the place values. One flat represents 1 rod represents 1/10, and one small cube represents 1/100. To get started, I'll make 3 columns to show the place values we'll be working with: ones, tenths, and hundredths. Then we'll represent the first number, which is 2 and 38/100, with base 10 blocks. So since a flat is 1, I'll put 2 flats in the ones place to represent 2. Then 38/100 is equivalent to 3/10 and 8/100, because 3/10 is equivalent to 30/100. So I'll put 3 rods in the tenths place and 8 small cubes in the hundredths place to represent 8/100. And when I read the number, I say 2 and 38/100, knowing that that's equivalent to 2 and 3/10 and 8/100. Okay, next I'll write the number that I'm subtracting, which is 1 and 52/100, or 1 and 5/10 and 2/100. Now we're going to take away blocks to perform the subtraction. Once I've taken away the 1 and 52/100 from the top, down into this gray area, the blocks left at the top will be the answer, also called the difference. So first I'll subtract 2/100 by moving that down here, leaving 6/100 in the top part of the hundredths column. Next, looking at the tenths place, I need to take away 5/10, or 5 rods. But this representation of 2 and 38/100 only has 3/10. Luckily, I can trade equivalent pieces. So I'll trade 1 for 10/10 and put those 10 rods in the tenths column. Now I have 1 and 13/10, so I can take away 5/10 from 13/10, which will leave 8/10. Finally, I'll look at the ones place and subtract 1 by sliding this 1 flat down into the gray area. And that leaves 0, or no flats. The blocks that remain at the top now represent my solution, or the difference. So let's label these columns with numbers. We have 0 ones, 8/10, and 6/100. I can also write this subtraction in vertical form, and in expanded form. So 2 and 38/100 is equal to 2 plus 3/10 plus 8/100. And I'm subtracting 1 and 52/100, which is equivalent to 1 plus 5/10 plus 2/100. Great, let's review what we did. We subtracted 2/100 from 8/100 and got 6/100. And I'll draw an arrow to connect that number to the base 10 blocks. Now let's look at the tenths. We had to do some trading at this place value because we didn't have enough tenths to subtract. So let's look at how we can use numbers to show the regrouping that we did. Remember that we started with 2 ones. Then we traded 1 for 10/10. So then we had 1 whole left, as well as 13/10, which I'll write as 1 and 3/10. Then we were able to subtract 5/10 from 13/10, and we ended up with 8/10. And here are the 8/10. Finally, we subtracted 1 from 1 and got 0. There are no ones. So our difference is 0 and 8/10 and 6/100. Or I can read this number as 86/100. So you can see for decimal subtraction that the base 10 blocks are really helpful for modeling and solving problems that involve regrouping. In this video, we showed an example of a decimal subtraction problem to illustrate strategies that you can use with your students to connect concrete and abstract representations. We encourage you to provide students with ample and meaningful opportunities like this so that students grow in their ability to use representations as thinking tools for solving problems.